Hey everybody, this is our Statistics Chapter 3, Section 2. This section talks all about least squares regression. Alright, a regression line is a line that describes how the response variable changes as the explanatory variable changes. We can use it to predict the values of y based on the values of x. Okay, we've been over some of this in class, so I'm going to go pretty quick. Alright, a regression line, it's y hat, you pronounce that y hat, equals a plus bx. The hat shows us that it is a predicted value, not an actual collected data entry. A represents the y-intercept and tells us what the predicted value of y would be if x was 0. So in other words, if the value of x was 0, what would y be? And B represents the slope, and it tells us, well, this is probably a new way to look at slope, it tells us the amount that y would change if x increases by 1 unit. So if I make x go up by 1 unit, it would then multiply by b one more time, so then it would make the y value go up by what b is. Exploration is the use of a regression line for predicting y values that values far outside the collected data. Do not ever do this. So in other words, if you've only collected data in a range of 50 to 150, you don't want to make a predicted value on 400. Because you've not collected any data that tells you what your data would do if you collected someone who weighs 400 pounds or someone who drives 400 miles a week in the car, or whatever you've collected data on. If your x values only go from 50 to 150, don't make a prediction with an x value of 400. Okay. Residual, the difference between an observed value of a response variable and the predicted value. Residual is equal to y minus y hat. So if you are asked for the residual, you would need an actual data point and then the predicted point from your least squares regression line. Your least squares regression line is a line of y on x that makes the sum of the squares residuals as small as possible. You can look at your book and see some examples of all this stuff. I just went through and wrote the books. A residual plot is the scatter plot of the residuals against the explanatory variables. They help to assess whether a linear model is appropriate. When an obvious curve pattern exists in the residual plot, we are not using an appropriate model. So you should not use a linear regression there. Alright. Standard deviation of the residuals. This is just a formula. If we used a least squares line to predict the values of a response variable y for an explanatory variable x, the standard deviations of the residuals is given by this equation. So we know that the summation sign, what that means, residual is y, the exact value, the observed value minus predicted value. So you would have to take all your residuals, square them, add them all up, divide by n minus 2, and then take the square root. But standard deviation of the residuals gives us a value. This value gives the approximate size of the typical predicted error. So how far are you typically away from your actual value? Okay. The coefficient of determination is r squared. Is the fraction of the variation of the values of y that is accounted for by the least squares regression line of y on x. We can calculate r squared by using the following formula. So if you remember when we put it in the calculator to find r squared also popped up. So if you want to know how you're finding r squared, well again, you take the residuals, square it, add them all up, okay, and then you put that over y each entry minus the mean of the y's. Okay, this one down here is the mean, not the residuals. How do you calculate the least squares regression line? First thing you have to do is collect both explanatory and response variables on n number of individuals. From that data, you would calculate the mean of the x's and the mean of the y's, as well as the standard deviation of x's and the standard deviation of y's, and finally their correlation. The least squares regression line is y hat is equal to a plus bx. We talked about that earlier. So how do you find b? Well, b is r, the correlation, times s sub y over s sub x. So the standard deviation of the y's divided by the standard deviation of the x. If you want to find a, you would need to do the mean of the y's minus b, which you just found, times the mean of the x's. So we'll do some examples. Many times they will give you the mean of the x's, the mean of the y's, standard deviation of x's, standard deviation of the y's, and the correlation r, and then you would just have to find the least squares regression line by using these formulas. Okay. Outliers and influential observations in regression. This last slide. So outliers, we already know what outliers are, but in this session, an observation that lies outside the overall pattern. Usually they're points that are outliers in the y direction, but not in the x direction, will have a very large residuals. So residuals are how far you are from your observed value minus your predicted value. So if the y is where it's an outlier, it's going to have a big residual. Finally, an observation is influential for statistical calculations. If you remove it, would it markedly change the results in the calculation? So in that practice quiz we did, when we had the one point that was way at the high point that had kind of a medium weight of the car, but its gas mileage was like 50 miles per gallon, 48 miles per gallon. That would be influential because it changes the residuals. All right. So I will see you tomorrow. We'll go over some examples of all this stuff.